I will talk about helicity cross-helicity dynamo in application. Then I will consider the generation mechanism. So this is an application of this formula to the galaxy. And galaxy is known to have some bisymmetric large-scale magnetic field. One is coming in and one is coming out. And using alpha dynamo, alpha omega dynamo or something like that. So people try to reproduce this configuration of bisymmetric one. And I submit this to A and A, and at that time Axel was a referee of my paper. I guess so. I sometimes review your papers sometimes, and maybe sometimes my paper was reviewed by. Anyway, so fortunately this accepted. Anyway, so I applied this model to the galaxy, and one point is that this is the rotational velocity of several galaxies, and this is the large-scale magnetic field magnitude of magnitude. So we have some correlation like this, and in order to express this inclination, we need W over K of 0.03 or something. So that means if we have very small amount of something like this. So we have this small amount of cross correlation normalized by K. Then we can explain this intensity of magnetic field itself. And I also in this paper I consider some asymmetry between the upper and lower galaxies. So it is known that there is some corrugation of density in the galaxy. So if we assume such corrugation, then we can reproduce in some sense. It's very difficult to recognize, but one is in some direction.
What is it? It's shown. This is distribution of magnetic field.
A magnetic field, but this is magnetic field. So this is upper half magnetic field, and this is lower half magnetic field. So if we, as I showed you, so with symmetric velocity, we have parallel and anti-parallel magnetic field. Then we consider B plus and B minus with U plus and U minus. But U plus and U minus is
it means you need a different sign of U W in two hemispheres.
Yes. But so with the same direction of velocity, we have very difficult. This is positive cross-helicity case. This is negative. And assume some corrugation of density of real galaxies. It is really observed. Then we can easily show this type of one. But that's very, very simple argument. But this is one application of this. And other one is accretion disk, also very long time ago. And in this case, we consider some Kepler rotation of the disk, and this is time, and first we gave a very small seed of cross-helicity, if I'm not wrong. Then start the evolution of equations, of model equations. Then K increase, U increase. Also,
so you solve the equation for the evolution of cross-helicity
cross-helicity, yeah.
as a function of time, yeah?
Yeah. Then
three equations for epsilon, for kinetic energy, cross.
yes, K and epsilon
And regional energy too. That means p squared.
No. In this work, no.
How
Only.
Put zero this parameter. How you?
Yes, in this system. Okay. So as the cross-helicity increases, the large-scale magnetic field increases. That's
So it is equipartition. It means.
And also, I already mentioned this argument.
If you put instead of equipartition, as you put in this calculation,
Yeah.
some portion for magnetic energy, the answer will change for cross-helicity.
You mean to add small-scale dynamo?
No, it's put it small-scale dynamo
Yes.
because residual energy, which is different between U squared.
I will show the equation for cross-helicity. And then, but if I'm not wrong, it don't contain explicitly the KR, residual of energy. So in this sense, such
Answer is
not so
sensitive.
yes, yeah. But
Let's hope for the best.
but also the residual energy is very important to produce the difference of the residual helicity. I mean, residual helicity depends on residual energy. Okay, so if we have large difference in energy of kinetic and magnetic energy, then we have it is probable we have a large difference between the kinetic helicity and current helicity. So in this sense, it may work. And also some magnetic pumping. For some magnetic pumping, residual of energy is known to play very important role. So, but in that case, residual of energy, I mean, deviation from equipation doesn't play much role.
It's a dynamo in solar wind? You're saying there is a dynamo in solar wind?
No, in accretion disk simulation.
But in solar wind, it's, why there is no
Of
dynamo?
course, in solar wind, in this case, the Alben ratio of 0.5 is the direct consequence of the finite residual energy, finite deviation from equipation between U scale and V scale. So in solar wind turbulence, residual energy is very important, I believe. But
But it's not yet a
Cross-helicity also very high, right?
yes, cross-helicity.
So you should have cross-helicity dynamo in solar wind.
I haven't applied the dynamo to the solar wind because maybe some people of geophysics interaction between the Earth's magnetic field and solar wind. For such situation, the dynamo can be very important. But the flow of the solar wind, I don't know what kind of argument can be do. Of course, dynamo is a universal phenomenon, but I'm not familiar with such argument. And this is application to fusion plasmas. So that means beta is very, very low. Beta, I mean beta, I mean
Plasma beta.
plasma beta. Plasma beta. So magnetic field is very strong. So it is known that there is many modes that improve the confinement time and so one is known that the spontaneous plasma rotation is observed in some enhanced transport barrier mode. So this is, I think this is my, this is first theoretical explanation of why if the magnetic confinement become very good, then experimental people observe some rotation, toroidal rotation in some location.
But internal transport barrier in tokamaks, it implies that there is a temperature drop.
Yes.
In the vicinity of barrier.
Yes, this occurs here. Also, I don't have any. Okay, I don't have any. But yes, and using some numerical simulation, I confirm. But this simulation is basically incompressible analysis, and so we don't we didn't consider such a density profiles. So it's very different. But still, with the effect of cross-helicity, if we have magnetic field and cross-helicity, then we have some kind of rotation. Some kind of rotation can be occurred due to the cross-helicity. Mediated by cross-helicity and some kind of shear of magnetic field, some kind of rotation can be produced. That's
Do you consider dynamical effects now, or because it's not?
Dynamical effect.
You also consider electromotive force, right, when we discuss?
Yes.
And now consider Lorentz force?
Of course, Lorentz force. But as I showed, Reynolds stress for the momentum equation contains cross-helicity term, nu m. So that's why.
That's a Lorentz force. Somehow.
Yes, kind of not directly Lorentz force, but work with Lorentz force. Yeah. Yes, work for cross. If we have finite cross-helicity in some reason, then it works for the driving plasma fluid.
Anyway, it must be an action of the Lorentz force. If there wouldn't be no Lorentz force, you wouldn't have this effect, right? You can have this effect only if there is a Lorentz force in the equation. So this would answer the question.
Yeah. But in addition to Lorentz force, we have Reynolds stress.
Yeah, that's clear. But the final cause of that is, of course,
Yeah.
of the Lorentz force.
In this sense, yes.
So it's kind of turbulent Lorentz force, right? So
Turbulent Lorentz force related to some mechanism to generating such effect. But it is not so clear at present. But yes.
So similar effect, I've seen your paper on Gaussian oscillations from the sun.
Yes.
It's a similar effect.
Yes. Similar effect. So in this sense, turbulent Lorentz force works for this plane. And this is cross-helicity dynamo applied to solar dynamo. And as I mentioned, if we assume some rotational motion in the toroidal direction, we have a magnetic field like this. This is primary one. Then if we have this type of motion, we have in the second order, we have some poloidal field due to the helicity effect. So here I consider the combination of cross helicity and alpha effect. The basic idea is that
no omega effect, you mean? Or you've got some sense you've got omega.
No omega effect. I myself don't.
So you keep omega effect in some sense. I mean, you keep vorticity in the induction equation.
Yes.
Last term, but you neglected vorticity in the first term of the third equation. Yeah. No. Well, yeah. I mean here. So this is differential rotation.
Yes.
You drop this term first of all, and after that, but it's a little bit, I think,
but for the cross helicity dynamo, as I showed, B0 is proportional to this, then this term totally.
You mean
okay.
And I perturbatively consider B0 field is first we consider cross helicity dynamo. Then take into account, take the alpha effect as a perturbation to B1 field. Then first we have B0 is this type of term, this type of solution. Then in the B1 field, perturbative field, we consider also alpha effect, alpha and beta, and but B0 field is coming from this first one, using this cross helicity term. Then we have this type of...
But how we can get oscillation in this situation? Not by hand. You should write equation, you should find the frequency of this.
That's next point. So then we have this type of term. Then we consider the effect of this term. That is primary field is like this, and the first order perturbation is like this. And also in the polar region we have this type of
Why do you change sign?
Pardon?
Because rotation, right? U is rotation.
U
is rotation.
U phi is
And
rotation.
B is proportional to U.
B is proportional. Yes, B0 is proportional.
Same direction, right?
And gamma change sign somehow.
Gamma changes sign. Gamma changes sign. Because
It was a
pseudo
question
scale.
white. Question white now. Because conservation, so you should somehow to get it.
Cross helicity is pseudo scalar. So most probable distribution is anti-symmetric. Cross helicity pseudo scalar.
Scalar.
Pseudo scalar. That changes
It's not a
sign.
vector product, it's scalar product.
Some.
Helicity is pseudo scalar because it's a vector product.
Yes.
Cross helicity is
Also,
scalar.
cross helicity is also
It's
pseudo
dot
scalar.
product.
Pseudo scalar.
It's dot product, right?
Dot product with polar vector and axial vector.
U, because it's U through vector and B is axial vector. So this integral motion should.
So dot product is pseudo scalar.
No, U is true vector, V is axial vector.
As I showed you,
But the
you
helicity, the same story. U is a true vector, curl U is a pseudo vector.
so this
You change sign, both you don't change sign of dot product.
so
Change B to minus B and take a dot product. You have same scalar.
What are you saying here?
I'm saying that because if change B to minus B and make a dot product, we still have the same scalar. Right? Why change sign only U?
Because it's with
Oh.
reflection.
reflection.
Under
So
reflection.
changing of plane, reflection, inversion of the coordinate system.
Change sign.
The signs,
Yeah,
U changes sign,
But you change
and
sign.
B it doesn't change sign. B is action vector. So cross elasticity changes sign. B is just like omega. Omega is called. So we consider the consequence of this perturbative field due to alpha effect. Sorry. So I don't have one. But anyway. So that field, sorry, very sorry. But B1 field affect as a negative to the production of cross elasticity. Okay, that's very important point. So we consider this type of solution, special solution. B is proportional to U, and then B1 field is coming from this alpha effect. But with this B1 field, the production of cross elasticity became negative. So first we consider positive cross elasticity, but due to the toroidal field effect, this cross elasticity, negative cross elasticity is generated. That's a factor to change the sign of magnetic field system. Okay. So we consider some toy model like this. So B0 proportional to U is written like this. The gamma represents effect of cross elasticity, and BP evolution is written like this. So very simple model. Then and also produced BP works for generation of negative cross elasticity, negative gamma. This should be gamma asterisk. Anyway, then consider the evolution of this very simple toy model. So even high school student can.
But it's more time dependent on the first equation.
I don't know. Just express this.
For simplicity.
For simplicity. Very simple. Yeah.
But finally, you have oscillations due to oscillations of gamma. Yeah.
One reason why I consider this type of very simple one is
But
that
I think it's possible to improve easily. If you take derivative
Yeah.
from the first equation, it will be b db5 dt if u phi is constant d gamma asterisk dt. To change d gamma dt by db5 dt divided by u phi,
But he
you
did
will
this.
get the two equation again with oscillation. So maybe
Yeah, but he has.
Then it's a growing solution.
Yeah.
but no growth solution.
No,
It's a
yeah.
growth. You're right.
Only
Because it's not
oscillations.
diagonal. It's just growth solution.
Yeah.
Not so simple.
okay. Then applying 2 times.
Possible to
We
get
have
good
this
oscillation,
type
but
of
no growth.
cross elasticity oscillation. Then we can estimate the cycle using this toy model. Then estimate the cycle using such estimate. Then what we said in this paper is that it is not inconsistent with the.
What's the typical time now, so that's interesting, according to your estimations? What's the typical time?
The typical time.
Is it possible to have 20
Yeah, so
years?
we need to know. LC is convection zone dips. So
one
it's,
third from it is known. It's
so-
one third.
So omega f is rotation time of the sun. Rotation.
Of course.
So we know. So one point is gamma beta over gamma. That is correspond to this one. So if we have
Very fast it should be. This
0.01 or something, and also this is the toroidal magnetic field to rotational velocity. Please refer to the APJ paper so sorry for what we show is that this estimate is not inconsistent with the observation of 11 years or order of 10.
To the emphasis of magnetic field. You also have thermomagnetic strands.
Yes, yes. So it our estimate depends on how to estimate these.
Yes, yes, yes.
So that's right.
So
What I said is I remember that using the density of this other formulas. This is written in Alben unit, Alben velocity unit. So it has a velocity, dimension velocity. Anyway, so it contains should contain some information of density. So it depends on how density we consider to estimate this. But upper boundary and lower boundary, we know some estimation of density. So the density range is not inconsistent with our estimation of 11 years.
7 orders of magnitude.
Yeah, yes, very. But
it's still more.
so this is very simple, but in some sense reproduce. The point is that so as I mentioned, first we have some toroidal magnetic field due to cross-elasticity effect. Then we consider perturbative alpha effect. Then we have perturbation field. This perturbation field works for negative production of cross-elasticity. Then cross-elasticity changes. That's our scenarios, but never verified in good sense. This is a PJ paper of Yoshizawa. So finally we consider the energetics of turbulence. So as I mentioned, this apart from the compressibility consideration, we have in compressive case we have total amount of OHD energy and total amount of cross-energy implicit constant quantities, as you know. So we consider turbulence density of energy and cross-energy. Then construct an equation for these two quantities with G equals K and W. And also we consider mean density and the point is that, as I showed in Navier-Stokes case, hydrodynamic case, the sink of the mean part is equivalent to the source of the turbulent part. So if we have a mean shear of velocity and mean shear of magnetic field, and also we have mean current density, we have production to the turbulent quantity. Then this is the equation for the turbulent energy, MHD energy. So this shows this is the production rate of. So as you know, mean field share, mean velocity share, coupled with Reynolds stress, produce turbulence. Also, if we have electromotive force coupled with current, it may produce turbulence. And primary effect is that primary effect is this one. So we have first this type of turbulent, if I say, dare to say, turbulent Joule dissipation. And also something else. So we have from this turbulent electromotive force, we have a production of turbulence. So this is dissipation, and this is also transport rate term. Okay. So next one is equation. This is the one we have to consider. So this is the equation of the turbulent cross-density. So they're almost the same form. We can. This is at this stage. This is exact equation. Then we have large-scale magnetic shear coupled with Reynolds stress. This is one production term to the cross-density of turbulent cross-density. The second one is EM dot omega. EM dot omega. So as I will show, so the primary one is that also this one. So we have this is very important. So if we have a coupling between a large-scale vertical motion and a large-scale current density with turbulence, beta, we have a production of cross-density. That is the second very important factor to produce cross-density. And the third one is I just mentioned to this one. This one with this divergence operator may work to produce something similar to omega effect.
If K isn't homogeneous, then kinetic energy isn't homogeneous.
Not homogeneous.
You need not homogeneous kinetic energy not to produce.
Oh, yes. Okay. So I will consider the mechanism that produces turbulent cross-density. So we this one and also this one. And as I mentioned, Reynolds stress is written like this. The Reynolds stress, you may disagree, but has some eddy viscosity type representation related to strain rate of velocity, mean velocity, and also strain rate of magnetic field. And also we have electromotive force like this. Then we can estimate like this. And as I mentioned, that this term is very important to produce cross-density. This is a coupling of mean velocity shear coupled with mean magnetic shear. Okay, nu K is almost the same to beta. So nu K is, if we have a turbulence, we always have positive nu K every time. Okay, so the second point is that as we can see, as I wrote, this term is very important. So third one is this one. So I consider some possible situations that make cross-density generation. One is that one I consider the generation due to strains, mean field strains. That one is like this. So I just consider in the fusion plasma case, to enhance the confinement and to enhance the temperature itself, neutral beam is injected in toroidal direction, sometimes in poloidal direction. But so in such a case, we consider this cylinder. If we consider cylinder, we have this type of profile of momentum due to the injection velocity. Then we have a large-scale toroidal magnetic field. This is machine center, and this is the inner side, and this is the outer side. So we may have some SM here is negative and positive. So due to neutral beam injection and coupling of the large-scale shear, these shear, large-scale shear is always exist. If reset is always exist due to the coil. And if we continuously supply neutral beam injection, we have this type of large-scale shear. Then we have some production and negative production in Tokamak class or subfusion. This is one situation I consider. The second situation is that generation due to vorticity. As I mentioned that if we have J dot omega, large scale J at omega, omega is large scale vorticity, then we have, depending on the sign of J omega, we have positive or negative cross-edge generation. Then I consider this type of cylindrical, with cylindrical approximation, we made some numerical simulation to this case. Then if we apply some rotational velocity to, in tokamaks we always have current, plasma current in toroidal direction. So apply omega in this direction, sometimes. Then this is cross-edge and this is applied omega. Then we have this type of dependence in the range of application. Then I consider some effect of turbulence energy suppression due to cross-edge. So if we apply a large-scale rotation, strong rotation, then energy of turbulence was suppressed to some extent in this region. Okay, so this is the effect due to sorry. Okay, anyway. Oh, okay. Okay, sorry. Okay. So this is the one I already showed. So there is no substantial conclusion here. So I now proposing some observation in solar physics. And as you know, pseudoscalar, this is the helicity calculation. Helicity, pseudoscalar has some spatial distribution. So solar sun, in the surface of the sun, there must be some spatial distribution of the cross-edge. I now propose this type of observation using Hinode. But as I mentioned, Hinode can only detect line of sight velocity, but with some assumption and model we can. So that's all. So.
Thank you.
So you actually, you are just proposing that it can be measured on the solar surface, but we then actually don't know at this point, right?
No.
Yeah.
As already the other people detected some urban wave in the solar surface. So that is in some sense equivalent to the cross-edge.
Yeah, but there must be systematic, of course.
Systematic, yes.
That may not be the case.
So Yeah, I'd like to know some spatial distribution and also time variation. I'd like to know.
That alpha effect to generate cross-helicity and the sound, right?
Alpha effect
You generate by alpha effect.
is related to cross-helicity oscillation. I think. Yes.
So which is effect is more important?
I
Alpha
think
effect or cross-helicity generated through alpha effect.
as I mentioned, I think as far as the solar magnetic field is concerned, I believe cross-helicity is primary effect.
Primary effect.
Primary. That's the reason I took as a basic field the cross-helicity. And alpha effect is only considered perturbative.
We need alpha effect to generate because there is no
No, alpha
other
effect
source
is
for cross-helicity.
important to change the cross-helicity. So due to the alpha effect, in my opinion, cross-helicity changes. And the changes of cross-helicity is essential to the changes of magnetic field polarity.
So what changes, what produces cross-helicity on the sun? Which mechanism?
In the
It's
sun.
neutral beams and you know the...
No. So in this sense, the alpha effect is very important. But it only changes the one. One thing is that cross-helicity is cascading quantity. So if we have some U and B in large scales, then we may have U prime and B prime in turbulence by cascade. So that's very important.
should give equation for solar dynamo.
Yeah, when you calculated the toroidal field in your model, I mean, how much toroidal field would you get if you use the solar differential rotation? I mean, this must be still a competing mechanism.
I agree with you, but
if you compare those.
in my formalism, or in my model, differential rotation is necessary just for maintaining turbulence, not producing toroidal field.
Yeah, but since you have a mean poloidal field, the differential rotation will automatically produce, through the omega effect, what's the toroidal field? Can you show that this effect is very small?
But you mean so U cross B term of the equation. So I must compare the U cross B term and cross-helicity term. But in genuine cross-helicity dynamo model with B parallel to U, in that case U cross B vanishes. In this sense, omega effect doesn't work in this scenario.
Yeah, but I mean, you have also
But
poloidal fields.
yes,
you should
I think we should estimate.
Can you show equations for solar dynamo?
Yes.
Then we can discuss this.
Yes. Or this one? Which one?
No, the previous one, yeah.
One would have expected that maybe the accretionless dynamo is perhaps the best scenario because as you have the strongest vorticity. Is there an argument that this may not be the case? I mean, the solar dynamo is...
Vorticity.
What?
Vorticity.
Yeah, an accretionless, you have very strong vorticity, mean vorticity, the Keplerian motion. Would you think that this would be a primary target? Or are there reasons to believe that
I
this
think
may
so.
not?
I think so.
Yeah.
Yeah. Yeah.
So the shearing sheet simulations that I did back in 97, 95, they actually don't show cross helicity.
Yes,
They do
but
show current helicity and they show also kinetic helicity.
I see. But
They're
in
stratified.
my opinion, the mechanism to produce cross helicity is very important.
Yeah.
Important, as you know. So that's my point. So especially in large scales, in large scales, if we have large scale cross helicity, I mean so cross helicity of mean field, then it's cascade to
Okay.
turbulent field. So the situation of such situation is very important for us to find the finite cross helicity. If we have no mechanism to produce cross helicity, we cannot expect cross helicity.
Yeah, but then how should we get this at large scales, this cross helicity? That's what you're saying, right? You would need that at large scales?
In solar case? You mean in solar
In
case?
case, you would need a large scale memory field already for that?
Yeah, in the case of fusion plasmas, NBI may play. NBI play. So, and also the poloidal rotation is very important factor in any sense. And in solar case, I'm not so sure about. I cannot definitely say what is the most important one. But as I show it in the disk case, the poloidal magnetic field coupled with some inhomogeneity of turbulence may work to see the field. So I don't know.
This model is the helicity changes sign in hemispheres, right? So then
Helicity
change sign.
change.
Gamma change.
During the change of the magnetic polarity, kinetic helicity never changes the sign, as you know. Only the cross helicity changes. And of course, other pseudoscalars, helicity and cross helicity changes their sign, northern and southern hemisphere.
Opposite sense in northern southern hemisphere.
Alpha change sign, it's a matter of fact. And gamma should change sign in order to get something similar to toroidal field. It means that B1 not change signs when we pass from one hemisphere to another. From another hand, we know that if we describe something so-called what we observe is similar to poloidal field. And this field, of course, change sign.
Yes, of course. As the polarity changes, you mean?
Partially. That direction not, but in
Yes.
This is too low.
U omega and DJ at polarity reversal never changes the sign. Never changes the same.
it's not similar at least to toroidal field.
But UV, U dot B changes its sign.
U dot B, no.
This is polarity changes. Polarity.
They are trying to compare this
Polarity, next polarity.
observation.
This is interesting.
This
effect is interesting.
U omega and BJ never changes the sign. But
Main explanation.
cross helicity changing must change sign because the change to B to minus B, BJ and U omega never changes its sign. Only cross helicity changes sign.
Okay, maybe you stop at this point, or maybe last question.
Yeah, I was thinking that what is the proper physical dimension of this cross-helicity? I mean, the dimensionality. So, I mean, if one writes this definition in the natural units of particle physics, for example, where the Planck constant and the speed of light are unity, then the magnetic helicity is actually a bare number. It is dimensionless. But I'm not sure what happens with this cross-helicity. Have you kind of thought about that? And what is the natural dimensionality of this?
Dimensionality.
Yes.
That's
That
dot product of U and V.
Yeah, so...
Dimension?
Yes, yes.
Oh, cross-helicity itself is in both in 2D and 3D.
The units. The
Yeah,
question
units,
goes
yes.
onto the units. Physical units.
Physical unit.
Yeah.
Yes.
Physical unit. How to say?
Velocity multiplied by
Just
Right?
I mean, of course,
velocity multiplied by v, just.
of course, you can multiply it by anything you want.
It's dimensional quantity.
Okay, so
It's
it's not...
dimensional quantity.
But you're saying magnetic helicity can
I
actually
think
be
it's
written as
it's a bare number if you write it in the natural units.
that's
section.
something else. Maybe not. How come? Because
Because the vector potential is kind of 1 over length, and then when you in natural units, and then when you integrate it, then you actually get a bare number. So it's length to power 0, which is bare number. That's the magnetic.
magnetic helicity has a unit of Maxwell squared.
Yeah.
That's what I'm used to. Because
Yeah.
it's like the flux
Yeah.
squared, of course. And that.
I mean, of course, after integrating. So
Yeah.
yes.
So that's after integrating. Then it's flux squared.
Okay.
And here, the thought will be different.
Okay.
Oh, then let us thank again.
okay. Thank you for your patience.
Quite interesting comments about these flows in data marks. I heard different interpretations that you due to change in turbulence. That's from here. This eco theory that is stretched turbulent by shear flow. And the interpretation is different from this.
You?
Effect on Lorentz force. Lorentz force.
Yeah.
People like diamonds and that eco that suggested that injecting turbulence and shear flow.